let's look at how our exponent rules can make operations with really big numbers or really small numbers a lot easier. So we're going to work with our numbers in scientific notation. Quick reminder, in scientific notation, your number, which I'll call A, is multiplied by some power of 10. This first number has to be greater than or equal to 1 and at the same time smaller than 10. And n is a positive or negative whole number known as an integer. Okay, so our first example here is going to illustrate our multiplication rule. When we have 4.65 times 10 to the 12 times 8.1 times 10 to the 8th, I'm going to start by using the commutative property to rewrite this. 4.65 times 8.1 times 10 to the 12th times 10 to the negative 8th. And the reason I'm doing that is I'm going to use my exponent rules where I have like bases. So with my calculator, 4.65 times 8.1 is 37.665. And here I have like bases, so I keep the base and I add my exponents. Now, this is almost in scientific notation, but this first number is greater than 10. So I'm going to shift the decimal point 1 to the left, making it 3.7665. Now, what I've actually done is I've divided by 10, so I have to compensate by multiplying by 10, which means I'm just shifting the exponent 1 to the right. I'm adding 1 onto it, so it'd be 10 to the 5th power. Just a side note is we've looked at ones where I say round to 4 significant digits. So if the directions would tell you to do that, in this case it would be 3.767, because the 5 would add 1 on, times 10 to the 5th power. Okay, let's look at a quotient. In the next one, I'm going to kind of group this like this. I'm going to divide 2.5 by 4, where I get 0.625, or 5/8, times 10 to the, take the top exponent minus the bottom exponent. So that's 9 minus negative 7, not 9 minus 7, which gives me 16. Again, almost done here, but I need to adjust this because this value is too small. It's smaller than 1, so it becomes 6.25. And what I've actually done is I've multiplied by a power of 10, so I compensate by dividing by a power of 10, which would be 10 to the negative first. So that shifts your exponent 1 to the right, making it 10 to the 15th. Now it's in scientific notation. Now, just a side note, both of these problems, if you type them in exactly as you see it, you would get on your calculator an answer that looks like this, which is a calculator's way of saying 6.25 times 10 to the 15th. So if your numbers are not too massive, the calculator can handle it, so it's a great checking tool. But the problem is with really big numbers, you'll cause your calculator to overflow. All right, this one illustrates the power to a power rule. We're going to take this outer exponent and distribute it to both factors, which makes this 4.6 squared, which is 21.16 times 10 to the, keep my base, and now I'm going to multiply my exponents. Almost done. Need to shift my decimal point, which means I divided by 10, so I multiply by a power of 10, which means I add 1 onto my exponent to make it be negative 7. Let's look at 2 application questions. The world population is about 7 billion, so I'm going to write that in standard form so I have a sense of what that looks like. And there are 4.6 times 10 to the 7th ants for every human on the planet. About how many ants are in the world? That's a lot. All right, so I have 7 times 10 to the 9th people, and then if there's 4.6 times 10 to the 7th ants for every 1 human, I'm going to multiply these, the amount of humans times the ants, to see how many ants are in the world. So if I do 7 times 4.6, get 32.2, keep my base, add my exponents to the 16th. Need to shift this, 1 to the left, 1 to the right, makes it 3.22 times 10 to the 17th ants. That is a lot of ants. I think they're all in my garden. All right, the next one probably makes a little more sense to you since you're big social media users. Instagram processes about 990 billion likes per year. Let's look at what that is. 990 billion. Which would be 9.9 times 10 to the 11th power. If Instagram has approximately 8.9 times 10 to the 8th users, about how many likes is each user responsible for per year? So this is really saying likes per year. So I need to put the likes in the numerator and years in the denominator, or the users. I take the total likes divided by the users. Okay, so if I do 9.9 divided by 8.9, I'm going to get 1.112. That would be to 4 significant digits, times 10 to the third. Keep my base, subtract my exponents. Likes per user per year. Now, that's in scientific notation. In standard form, just so we have a sense, that would be 1,112. You'd shift your decimal point. Likes per user per year, which is probably quite low. If we ran numbers again today, I would suspect that it would be much higher. That's only like liking something like 3 different items a day. Okay, so you should be able to compute with large and small numbers using scientific notation.